Anna, and welcome to our today's lesson. And today we continue with what we had started, volume and capacity. And today I want to explain a few questions that are very technical in class 8 about volume of troughs and solids. So that's what I want to deal with today. And to begin with, to show you what a trough is, a trough is gotten when you, for example, you have a cylinder. Take for example a drum, and that drum of yours, you cut it into two equal halves. So you cut it here across like that into two equal halves. You'll have this one half and the other one. So the first half will look like this. The downward half, I'm looking at this. Now I draw that and it will appear like that. That's how it will appear. Such that it has this longer side, which is here, then the other side, because you cut it into two, you see that these which are equal. Then we have the diameter, which is also the same as this diameter. Then we have the curved surface. So we want to see how to calculate volume of troughs. So assuming our trough here is having a radius, a diameter of 14 centimeter and a height of 10 centimeter. Can you be able to get volume? So volume of cylinders is calculated by pi r squared h. If this now is the volume of a cylinder, that's how we get volume of a cylinder. For us to be able to get volume of this, now remember this is our cylinder. The cylinder that has been cut into two like this. So it means volume of this is going to be pi r squared h over 2. You divide that volume by 2. Because this is a half, so that when you enclose it here, when you complete it, now it becomes a full like this one. So that is what we do. So we begin here. We are using the pi as 22 over 7. So we use pi 22 over 7. So the volume will be equal. So instead of saying pi r squared h over 2, you can say half of the total volume of this when it is full. So times. So you multiply by half first. Initially, when it's not half, here is 1, but you don't write that 1. But because now it's half, we must write that half. So half, you will not divide by 2. These 2 here came because of these 2 you are seeing here. So it's half pi 22 over 7 times radius. The radius would be the diameter divided by 2. So 7 times 7, then times the height, which is 10. So this is going to give you 11. 7 times 10. So this is going to be 770 cubic centimeter. That will be the volume. If they ask you the capacity, then maybe in liters, you exactly know that 1 liter is equals to 1000 cubic centimeter. What about 770 cubic centimeter? Is how many liters? So you cross multiply. That will be 770 cubic centimeter times 1 liter over 1000 cubic centimeters. Cubic centimeters will cancel. This 0 will cancel. You remain with 77 over 100. Remember what we said when you are dividing with zeros? The decimal point of our number is at the far end. So when you are dividing, the decimal point moves backwards. So it's going to move backwards 2 times. 1, 2. So it becomes 0.77 liters. If you are to write it in liters. So that is one. I want to give you another one. Want also to get volume over this figure here. There is a figure here. Drawn like that, such that the radius up to that point is going to read 3.5 centimeter, and then the length is going to be 12 centimeter, which is the height. And then the volume of the smaller one here. Remember here we have two shapes. We have this groove here. Let me shade this one. We have two shapes here. We have the groove. Groove is not what is not there. When you drill through a log of wood, you drill and leave a hole like this, which is through. So that means that this part is not there. This part is not there. So you want the volume, and this seems to be a solid. So this is going to be a solid. So it's no longer a trough, but it's going to be a solid. So you want the volume of this solid. The volume of this solid is going to be the same, only that there's part which is not there. This part here is drilled and it's not present. So we are going to remove it from the whole volume. So learner, be careful in this question because it comes in an exam. And I want to explain it well that if you get a question like this one is different from when we have this one from this one. This one, at least this one is a full one. Every part is there. But this one, there's one part which is absent. This part here. That's why you can see a hole. So we have to get the volume of the whole one minus the volume of this hole. So it's going to be, because the hole is also in shape of a trough, but it has same height of same one as the big one. But now the difference comes in on this particular diameter. This one has a diameter of 0.7 centimeters. This one from here up to here. That's the only difference. So we are going to get the volume of the bigger one. The volume of the bigger one, I'm going to represent that with a big R. So the volume area, so volume will be the volume of the bigger one, pi R squared H, subtract the volume of the smaller one, and I'm going to represent that with a small r, pi R squared H. So that you can just know what we are doing. So the volume will be, what is the volume of the bigger one? Pi, and now look here, learner. This is half, so we are going to divide both by 2. Just like that. Because this is an half of a cylinder. When you write pi R squared, is for a full cylinder. So for you to get half of that, you divide that by 2, divide by 2. So 22/7 times the radius. The radius of the, okay, let me start with half. Half pi R squared. Half pi R squared H minus half pi R squared. So let me give you the half times 22/7. The radius. Now look at the radius. Now if you see something coming from the circumference to the center, I say that is a radius. So it's going to be 3.5 times 3.5 radius squared times the height. The height is this one here, which is going to be 12. And you put a bracket because there is something else we are also doing. And you open a bracket there. Subtract half pi radius now of the smaller trough, which is going to be the diameter. If the diameter is 0.7, meaning that if you divide this by 2, you get the radius. So I just say 0.7/2, that becomes a radius, times another radius, 0.7/2. I'm avoiding to write, if you divide this by 2, you will get 0.35. I don't want to write 0.35, so I can just write 0.7/2. I don't simplify it, then times the radius, then times the height is also 12. So you must understand what I've done there. And then I close this bracket. Here if I calculate well, I get 11, 0.5. Now this will be 11 times 0.5 is 55. 55 times 35. That's where we begin. 55 times 35. 5.7. 5 and 116. You get 5 to 9 to 29, 25 times this 12. 0, 5, 18 can 1, 5, This is 5, carry 1, 2, 9, 2. That will give you 0, 0, 11, carry 1, 10, 5, 3. 3, 5, 1, 0, 0. But we have how many decimal places? 1. So you're going to be 1. So this is going to be 3,510 cubic centimeters minus what we get here, 0.1, 0.35, 6. So that's going to give you 11 times 35. 11 times 35 is 385. 385 times 6. 0 carry 3. 48, 51 carry 5. This is going to be 1823. How many decimal places? 1, 1, 2, 3. 1, 2, 3. 2.31. So subtract 2.31. So if you calculate 12 here, so this one 2 decimal places, not 1. That is going to be 351. So it's going to be 351. 351 cubic centimeters minus 12.31 cubic centimeter. And you subtract it 12, 351.00. Because these are 2 decimal places, I place 2 zeros there to just make sure that they are the same. This is going to be 9, 6, 4, 5. Sorry, can't be 5. This is going to be borrowed 1 year. Borrowed 1 year to be 10. This is going to be 8, 4, 3. So answer now becomes 348.6169 cubic centimeters. There's one thing I want to insist here, learn that when you're given a question like this is half, then what is not even there is also half. So you start by writing the formula first before you working out the question. If you write the formula right, you get the other questions right also. So I want to leave you with some work here. Now that you have understood what you're exactly supposed to do, I'm going to give you a few questions on this, and that is going to be exercise 74. 74 is a revision question, a revision exercise. It's a mixed exercise actually. I want you to attempt questions from number 10 to 15. That is on page 123 to 124. I want you to do this. There are only 5 questions. I'll be given that because I know at the end of the day, the question number 15 has 4 questions of what we are doing here. So that I want you to get that right. So I want you to attempt that exercise. And then tomorrow we are going to do capacity, and then we see exactly what we're supposed to do. So until next time, learner, I want to wish you well. May you remain safe at home and be very busy doing something back at home. Thank you.